Not at all. No, maybe something is wrong with the microphone. Hello? Hello?
Hello?
Yeah, can you hear me? I can hear you.
Yes.
Okay, good.
That's good.
So, yeah, sorry, it's really bad about it's really bad thing. So, I bought a horse and I went to take her to the forest and just short walk for 1 hour, and I should be back before 7 p.m. But she got naughty, and I had to pull her back, and she's half a ton, so it's not easy. She's not working with me. So I just got back home 5 minutes ago. So it was
No problem.
was terrible. Yeah. So I should anticipate this in the future. Yeah. This is the first time I take her out to the forest.
Okay. Yeah.
Anyway, yeah. So damn it. Okay, so what I want to show you is this document. Okay. So I know you worked on secret sharing, like I'm sorry, a multi-party computation of RSA signature, right?
Yeah.
Yeah. So so I thought that in that setup, so there are two things. One is secret sharing, which is I'm just explaining my understanding. Correct me if I'm wrong. That there are multi-party keeping shares of keys, and there's a threshold of keys to key shares to obtain in order to reconstruct the secret, and everybody does a resharing thing once in a while, right?
So there's different ways of doing it. This is what you're mentioning is one way of doing it, but
Yeah.
It depends exactly on which scheme and what you're using. So I mean, you can also like how it's used with RSA is usually that you have shares, and then you can construct either a shared signature or a shared
Yeah, that's the
shared
other way.
decryption.
Yeah. So the first method I mentioned only reconstruct the secret, and second one allows you to do computation like signing stuff, right?
Yes. Yeah.
Okay. And for the signing stuff, then do you still need to do resharing?
I mean, it depends. So you don't necessarily need to do resharing. Resharing is it can be used in some schemes to increase security in such a way that if you have say you have 3 parties with shares, and 2 of the parties have been compromised at some point, so the adversary knows their share. Then all 3 parties can later do an efficient resharing, such that the adversary cannot use his shares anymore.
But wouldn't the same attack work if the RSA like an MPC method, the nodes gets compromised? Or that do you set a threshold that one of them has to? So do you do resharing in the MPC method, in the signature in signing RPC signing method? Sorry, MPC.
I mean, you don't do it as part of the signing. You do it as like a separate procedure, which you can between the parties decide whenever you wanna do.
So
and I mean, like the key.
Yeah.
The key is that the adversary is, of course, well, it doesn't have any of the parties compromised while you do resharing, because if he does that, then he will, of course, learn the new share.
Yeah. So the same assumption would apply. Okay, let's say there's an old secret sharing method which involve resharing, and there's a new one which never reconstruct secret, but instead construct signature directly through multi-party computation. So let's say just call it old method, new method. So the same assumption that the key gets compromised in time in the old method, isn't that assumption also valid in the new method? That if I compromise these nodes one by one in time, then I can just reconstruct the signature, whatever.
Yeah. If you use the same key, I mean, like basically, if you move from using old method to using new method without changing the master key, so to say, then of course, if the adversary compromises the shares of the old method of all the parties, then he will know the master key.
Okay, let's suppose someone start afresh using a new method, like the
Yeah,
key was generated in multi-party computation, not used in the secret sharing before, so nobody ever knows the key. Now,
yeah.
in this new setup, wouldn't the adversary still be able to compromise it by slowly compromising different storage space of different parties?
If he does, he can if he does all that in between a refresh.
So there's
So I
still
mean, if he
refresh
manage,
needed in the new method.
there's still like if he again if he compromises all parties without refreshing, then he knows the master key.
Yes, which means refreshing is still a reasonable procedure in a new method.
It is definitely still a reasonable procedure. Not everyone does it,
Yeah.
but I mean, it's definitely reasonable to do. I mean, normally you would generally like the way things work now is you first of all you don't assume that your key, even if you're not using threshold, you don't assume that your key gets compromised. I mean, you do still like, but instead you do actually nowadays often, or you should often do refresh. So then the idea is like, oh, okay, let's do threshold instead, and we don't have to worry about the refreshing, because then you need to compromise several parties. But then again, I mean, that can also happen that you actually do that, and that's why you can still do refreshing as well.
Yeah.
Uh,
So the reason I'm talking about refreshing the keys is because once the key is discovered to be compromised, it's quite difficult to move the the assets cleanly from one key to another. So let's suppose it's a bank, right? So if the key, if there's no refreshing protocol, and let's say some parties suspect that the legal owner of the key suspect that it's already compromised and there's no resharing, then the legal owner of the key can usually approach the bank and say, now I don't want you authorize transactions with my old key. Let's start with the new one. And the bank will say, okay, your stock share, your everything, they don't have to change. I will just remember that in the future, if you want to move your share, if you want to move your home loan or stuff, I will accept new authorization. That's what happens in the
yeah,
bank. But
yeah,
there's no clean way to move assets from one address to the other um, in Ethereum. Effectively, you have to transfer every
yeah,
asset you are holding in Ethereum to a new address. That is a
yeah,
lot of transfer, and some smart contracts might restrict the way you can transfer.
yeah. Okay.
So that gives me a feeling that resharing is actually more important in the blockchain scenario.
Yeah.
Make sense?
Yes,
That's
and it does. It does.
because if it's compromised, you cannot easily change the key. Now, in that regard, yeah. So this is topic number one. That is resharing needed or not? Then I just explained my analysis of this and just confirm with you. And the other thing is, I asked colleagues to produce a. So imagine that with the old method, secret sharing, then imagine that the key is, then there are two ways to use it. Either that the key is reconstructed from shares every time when something needs to be signed, or that the key is used as a backup, and every time when something needs to be signed, one computer already have the live key and can just sign it off. And if the computer is destroyed, you can reconstruct the backup from multiple parties. And these parties are only able to do backup, but not sign stuff on behalf of the user. That's one way, which is to use it as a recovery method. And the other way is just to reconstruct the key every time when you sign it. That's if we talk about old secret sharing method. Make sense so far?
Um, I think I missed a little point of that. Could you repeat it again?
Okay, so let's not involve MPC at the moment,
Okay. Yeah.
and then we will talk about MPC. If without MPC, there are only two possible ways this would work for a user. Let's say suppose user wants to secure his asset and authorization key of the asset on blockchain. So there are only two ways to use the old method. One is that the user does not have have some means to get all the parties to start reconstruct the key for her every time when she needs to sign something. Maybe she can call all the parties and say, okay, I need to sign something. Let's reconstruct the key. And the other is the user simply keep the key in his mobile phone, in his computer. And then if he loses it, he can call every party and reconstruct the key. And when he's not losing it, the other parties can do a key refresh without him, because he doesn't actually keep a share of the key. He keeps the entire key. So that's the two scenario we can use. And actually, I have a story for the second way, which is mainly to use secret sharing as a means of backup, where user have the full key and does not participate in sharing, and other parties participate in sharing, and the other parties are not able to sign stuff on behalf of the user unless they collide. Okay. So the story is I got the story straight. So we have a flow that might put this technology in mobile phone, and I just want to go through with you to see if everything is practical, and then we enter the MPC method a little bit. Okay. So I just sent you a Google Doc. I don't know if you have the right to see it. I can download it and share it to you if you don't.
I can request access.
Yeah. But it's probably not my doc.
Okay. Well,
somebody shared.
I still requested access. Okay, let's see if I can. But yeah, if you can send it to me, then that will probably be the best.
Okay. So let me see. I think it's the file. Yeah. Can you see it?
Yeah, I see a PDF. Hold on, give me a second.
Yeah, Zoom chat.
Yes, I got it.
Okay, so I'll walk you through this because later there are two things. If it works, there are two things I need your help from. One is if the process seems to be secure. The other is, can we salvage existing software to make this work? Okay.
Yeah.
So it starts from the user. Look at the user settings, where the user can do set up wallet recovery, where the user is. Let's ignore the second option. The first option is the typical one: set up secure vault.
Yeah.
Okay. Then the user. Actually, this is outdated chart. Wait a moment. This is outdated. Sorry. So it seems Lucas didn't update document. That's not very good. Okay, now this is the new one. I'm sending it to you. This time it's a web page.
All right.
So are you seeing the link to Envision app?
Yes, I got it here.
Yeah, thank you. So this is a live demonstration. Sorry, this is prototype. So there's set wallet recovery. Let's click that. And there's a multi-factor vault.
Yeah.
Okay, click that, and then there are two things the user have to do. First, step one, user choose to identify himself as using email or SMS, receive verification code. And this information at the background, at this moment, the mobile phone is going to be connected to, let's say, 2 out of 3 parties, okay? 2 out of 3. So at this moment, the mobile phone will verify if the user actually owns the email address or the SMS mobile phone number. Either one of them it will do, just one. And then send the email address or the mobile phone number to all 3 parties. So this is shared between everybody. And then step 2, let's go to click any one of them, email, for example.
Yeah.
Step 2, let's click verification link and then verify and return the app. You are there?
Yeah.
Now we're at step 2. At step 2, the user provides answers to 3 security questions. And when the user click confirm, these 3 answers and questions will be sent to 3 parties individually, not shared.
Yeah.
So in the first step, user set up verified email address or mobile phone, which is shared between 3 parties. And second step, user set up security question, and these are not shared between 3 parties. Instead, the first party gets the first question answer, the second party gets second question answer, and third party gets a third question answer.
Yeah.
Okay, and then the user confirm and do the backup. And this is the moment when the key is shared into 3 shares, and the 3 parties start to do the resharing, let's say every day or something.
Yeah.
So this is the starting process. The recovery process is, I can just describe it to you. The recovery process is that the user contacts 3 parties individually. And for every party, let's say party A, first party, the user reach out the first party. The first party will ask the user to verify the email address or SMS, send a code, and the user will answer that. And then the first party will ask the first security question, and the user will give the answer to the first security question. And then this is done for the first party, and the user do the same for the second party, for the third party. Once the user have done to all 3 parties, the 3 parties it's considered that the user authorizes 3 parties to enter the key recovery protocol. Then they will do a key recovery and then send the private key to the user's mobile phone. And the users use a mobile phone to do this all the time.
Okay.
Yeah. So this is how we envision user can use the secret sharing as a key recovery method.
Okay.
Yeah.
All right. Yes. Okay. So first question. So exactly the case we want to protect against is if the user loses his copy of the key.
Loses
and
the
I assume
mobile phone. Yeah. Yeah.
Yeah. So the user loses his mobile phone, right? So I guess it would be a bit of an issue in this case to use the mobile phone number as recovery, because if the user loses his phone, he will most likely also use his SIM card, and he may or may not be able to get that number back from the phone company.
Yeah, that's right.
So that's just something to keep in mind. So I think the email is definitely the better way.
Oh, by the way, it's assumed that when the user starts recovery process, the user will generate a private key, a temporary private key, to go through the process, because I think the final key is going to be delivered to the user in the encrypted format.
Yeah. All right. Great. So I'm a bit wary of the usage of security questions. Since in practice those have often been shown to not work that greatly. But I see like the main mechanism in this case is basically that the user has access to the email address associated with his account.
Yeah, you're right. Can I comment on this?
Yes.
So I don't like the security action either. But there is so you know this 2 out of 3 thing, that you need to provide something you have and something you know in combination that would verify.
Yeah, exactly. Yes.
So email is something you have, and which because it's not sharing any secret. You're not sharing the email password. You are sharing. You are validating your own email address. So it's something you have. Better would be a key holding device, but the user already lost his wallet. So email is what you have.
Yes, exactly. Yeah.
And the next thing is what you know, and what you know cannot be shared between the three parties. Otherwise, the guy who compromised one party can simply compromise the other through the shared knowledge. For example, you cannot set up a password and then let all three parties know the password in order to verify the user. Because if you do that, then you just, the adversary can only compromise one host and then pretend to start a recovery process and use the knowledge to compromise the other two hosts.
Yes, but I mean, you could.
Which means, sorry, let me finish and finish really soon, one sentence. Which means if you use any what you know method, knowledge method, then the three parties need to learn different knowledges. So whatever you configure, password, PIN, or secret hand thing, has to be three different ones. Now I finished.
Okay. Okay, so I totally follow your logic. Makes sense. I do think that I mean, the parties don't necessarily need to know this this knowledge in plain. Okay, so let's just like a stepping stone say
Hash-based method.
Yeah.
That is if every party is actually following the protocol, which can be done because...
Which we're not assuming that they are, yeah.
But it can be done because maybe because the process starts with mobile phone, the mobile phone can simply send the hash to them. And then, but if the process starts from the mobile phone must, in the setup phase, send the hash to all three parties. And in the recovery phase, not send hash to every party, but instead ask the user to individually talk to three parties.
Yeah, I'm just thinking, I mean, you could, so, I mean, I'm just trying to figure out the simplest way of of achieving this, because so this is probably not the simplest way, but incidentally, me and my colleagues just have a new paper published on,
okay, talk with me about
it. Yes, on distributed password authentication.
Okay.
So basically, the idea behind this is that you again use a threshold scheme to basically verify that that the user knows a password, and this is done in such a way that each of the parties cannot even brute force the password individually. Unless they're all if they're all colluding, then they have the option of brute forcing, like any hash. But I mean, we assume they don't. So that's definitely a way of doing it. I think it might be a bit overkill in this setting.
Why is overkill? Because it looks simpler to the user. It actually is underkill. So why is it?
No, I meant implementation wise.
Oh, okay. Because it's on paper and hasn't been implemented.
We did an implementation, but it uses a couple of advanced cryptographic primitives, like think of elliptic curves on steroids.
Okay, so it's complicated.
It's not that bad. It's just there's not a lot of libraries implementing these scripts. I mean, there are. I mean, we did it in Java, so it will definitely. And we're actually also going to implement this in the coming month to work on Android. So it's definitely doable to use as an app. So there is.
I can just read the paper.
Yeah. There are less like if you just want to. There's other protocols for password authentication in the non-distributed way. where you don't actually where the parties don't actually have a hash of the password. Instead they execute a protocol like Diffie-Hellman and something that's similar to Diffie-Hellman key exchange, based on a user's password. So and then they to verify that the user actually knows a password, but in this setting, the server will never actually know the password. It'll have some specific information during setup that's based on the password, which it can use to check that the user actually knew the right password.
Okay, just out of curiosity,
yeah.
when following that method, maybe is it like, for example, hashing the password and use that a private key to generate public key, and then do Diffie-Hellman against the other public key? Of the
not exactly.
Okay, yeah. Anyway, sorry.
But you're onto something. Like it's related to those ideas. So I think maybe if basically when the user sets up a password, it uses the same password for all three backup providers. And basically it will run different instances of these password these special password verification protocols with each of these parties. So this basically means that none of the parties will ever learn the hash. Will
other
ever
parties,
learn.
Okay.
Yeah. So this
from
means
one
they
knowledge,
cannot,
everybody gets different data to
yeah, exactly. So yeah. So this means they cannot fake towards the other. They cannot pretend to be the user towards the other parties in a reconstruction unless they actually know the password. So in this case, they can still they would still be able to brute force it, whereas in our paper they will not be able to brute force it. So like in the classic, which is known as PAIG, password authenticated key exchange, or key agreement, they in a non-distributed way or in the non-threshold way, they can brute force the password to try to impersonate the user, whereas in our new paper they can't. So I'm just gonna send you a link to this new paper.
So what is the, what do you call it?
It should be readable, at least the beginning.
Okay, good. That's good to know. Yeah, I got the link. So the Diffie-Hellman key like method, do you have a name for that? That one, yeah, the one that uses Diffie-Hellman key and uses a key derived from private key, from the password.
It's generally called password authenticated key exchange.
Okay, so it's called password authenticated key exchange. Okay.
Yeah.
Okay. So
for sure.
Yeah.
That's the general one. Yeah. So I think that might be at least at the beginning sufficient for you guys. But again, like in this case, in the distributed setting, you still have the issue that one server could try to brute force the user's password and impersonate itself towards
because it has
other
all knowledge to do it locally without collaboration.
Yes. Yeah. But then it would also need to compromise the user's email address as well to be able to do so.
No. So if I
you don't want it to I thought you wanted to also
that's for the parties to enter key recovery process. We want to validate every party to validate the user's email as well as the password. But if one of the parties wants to brute force, yes, I see. If the one that party wants to impersonate the user to enter key recovery protocol with the other party, he still needs to crack the user's private email address. Yes, that's right.
Yes.
Yeah, that's right. Okay. Sorry, I was one step behind you. Okay.
No worries. Okay. So this might be sufficient, and if not, you can. There's a link in our. Let me see if it. We're updating the paper right now because we just got it accepted at a conference, and we're making some slight readability changes. So we will update this link when we're done with that. I can also hold on. Let me send you the link for the source code.
I think yeah, you're right that only the first 3 pages are somewhat readable. So if you update it in the other pages,
it becomes like the implementation section should also be readable, but the last section. But hold on, let me send you. We have also, just so you have it. Send you the link to the source code. Sorry.
I hope you are fine these days and not having flu.
Yeah, I'm good. How about you guys?
Yeah, I'm healthy. People, I'm not going to the office anymore. Working from home.
Yeah. I guess everyone are these days.
Normally, I don't have the time to work with a horse, but the coronavirus gives me the opportunity to do so, because usually I travel everywhere around the world and have not time to take care of a horse. Now I'm at home, so I would just do that.
There's a silver lining to everything. Here's the link. But so the simplest of these PEG protocols is the SRP protocol. I'll send you a link to it, but it's I would recommend hold on, let me find the link. A newer one, because the SRP protocol is not provably secure, and it's had a lot of weaknesses and have been updated a bunch of times, so it's a bit iffy. So this one, I just sent you a link to another paper, which is
upgraded version of it.
Yeah, basically, yeah.
Okay. PEG protocol. Yeah. So what we need to do is to write down all of the candidates methods we have, and then I will do this in a long email, and then we start to talk about advantages and disadvantages. We are looking at 3 aspects: easy to use, which means the user has to do not something very different than the user normally do with a mobile phone. Then the second thing is implementable in a predictable date, because if we roll the product out, we need to have an estimation. And the third is security, of course. So we will evaluate these things, and we will security. Basically, we're evaluating the attack methods against each one, and then that will. Yeah. I just try to write an email to start this conversation.
All right, great. Yeah.
Okay.
So I think using a normal PEG for each of the for each of the backup servers is probably the simplest way to start.
Mm-hmm. So the core thinking is that there's a secret sharing protocol, which is already known and working, and there is the authentication against the party, which is the new problem we need to solve. Not exactly a new problem, but it's an issue when you recover it. Because you don't have the key anymore, how do you let every key sharing party to recognize you? So back to the MPC thing. I said that let's talk about it in the end. So the thing I'm thinking is the user cannot participate in resharing because the user is on the mobile, unless every other party can follow the timeline of the user. Let's say the user's mobile phone do resharing once a day, and whenever the user decides to do it, everybody else have to say, "Hey, let's go to work."
Yeah.
So is that reasonable? Like instead of regularly resharing, reshare according to the user's trigger, and would that create some attack parameter?
I don't think so. I mean, like, the resharing itself is not should not be dangerous in any way, and I I don't think, since we don't really want the user to keep a share because we're protecting against the case where the user loses his
But if the
device.
user don't have the share, the user has still have the key authentication to convince everybody else is the user. Because otherwise,
What do you mean?
Okay, let's say if the user don't participate in the key sharing protocol, the user simply
Yeah.
ask the key sharing protocol to give me the signed stuff, right? Yeah.
Yeah.
Let's say we use this method, then users still need to authenticate against everyone in order for them to enter the signing process. And to convince everyone, the users still need to authenticate.
Okay. I'm sorry, I misunderstood. I didn't. We're in the other case. Sorry. Yeah, we're in the other case now. Yeah.
Oh,
right.
Now I'm confused. So
Okay.
I thought we. Okay, I see. So the key sharing protocol doesn't work as authentication protocol at the same time, or does it?
When you say key sharing, you mean key sharing or key or
Sorry,
resharing?
MPC signature generation, MPC signing.
MPC side. Okay. I mean that's basically an interactive protocol, and it's not necessarily linked to refreshing or anything like that.
Oh, okay. So if we use that, we forget about refreshing.
I mean, you can still do refreshing. I think we're misunderstanding each other a bit right now. You can still do refreshing, but yeah, it's a different method. So if
Maybe let me ask a question. So
yeah.
let's say there's a multi-party MPC signing algorithm, and there are 3 parties. So when one party enters the protocol, does he has to authenticate against other parties with, for example, key challenge response first, or does he just enter the protocol and just straight into it? And if he doesn't have the right right knowledge, he can simply the process can simply cannot go on.
Exactly.
So is this so it's authentication and work, or MPC, or just directly go MPC?
It's direct. It directly go. You don't need to do authentication, because if you don't have the right information, then when you combine everything at the end, it will not be valid.
I see. So in this case, the user who wants to use an MPC protocol can simply be an MPC partner. What's the advantage of not doing that?
No advantage, except then in this case, then the user will also have a share of the key. And then there's of course a problem, since we believe there's a relatively large risk that the user loses his key compared to the backup services.
Ah, I see. So because in this case, there's no 2 out of 3.
Yeah.
Well,
I mean, like you could do that. There's a lot of options here. There's a lot of possibilities, which is both good and bad. So you can set it up as any kind of way you want to do it. Yeah.
Oh, I see. So in the typical case, when there's a multi-party signing protocol is running, it's not a threshold protocol, typically. Is that true?
I don't know if it's typical or not, or if it's threshold, or if it's like you need everyone to take part. I'm not sure there's a norm. You can do either. It's not a problem. The simplest implementations, the simplest realizations of this is, of course, if all parties need to collaborate in order to construct a signature.
Okay, so the reason I'm asking about whether or not the user can participate MPC with the mobile phone directly, the reason I ask this is because if the user don't do this, the user will still need the key, and the user still need to convince every party that he intends to sign something with that authentication key. And that's actually still pretty weak, because anyone else who obtained the user's mobile phone probably can use this same key, but the same goes for it's actually easier, because the user can somehow, let's say, verify email address or something to contact the parties to revoke the authentication key. But if the user have the secret sharing key, is it easy to revoke? Anyway, so am I right if I say that basically once you enter MPCs, it gets a lot of more complicated and probably shouldn't be done on a mobile phone unless somebody already did it on a mobile phone?
I'm not necessarily saying that. I mean, it's of course it's a different different setting. It's a different use case than the backup setting. So it needs to be tackled, and with different considerations in what exactly we're trying to do and protect against. But it's not necessarily that it's too advanced an issue. That being said, like the protocols for distributed ECDSA signatures, which is what I assume we're looking for in this case, do get quite complex because of the mathematical nature of ECDSA. You basically need to do a little bit of MPC to construct a distributed signature. Whereas if you use RSA signatures, it's much simpler. But,
so there is a way to construct to construct a RSA signature without using MPC distributed.
Yes. RSA is super simple because the math in RSA basically just means that you have an additive share of the secret key, and everyone just does the normal RSA signature and just multiply everything together, and then it adds up. Then it's a proper signature. Whereas ECDSA, the operations are a bit more meh, especially because you take something from the curve and then you take one point and you reduce it, modulo some value, and you do some inverse and addition and yada yada yada. So that one's not as easy. RSA is super easy to do this with.
Okay, yeah. In practice, we will need ECDSA. So
yeah, exactly.
So let's open two separate discussion. One is about key recovery, mostly focused on key recovery, and that's about different way to authenticate parties to use to enter a key recovery protocol using the traditional secret sharing protocol. And the other is it possible to use MPC ECDSA signing entirely so that the user's local device does not have the private key at all? So these two things, let's discuss them separately because they are two different realms, I think.
Yeah. So I just wanted to mention in regards to the latter, there are several companies that are already looking and doing products based on that.
ECDSA, MPC signing.
Yes, for blockchain.
Okay, good. So so let's. I will write 2 emails, and in the second email, when we talk about that, can you reply me with the information you know?
Yes.
Like for awareness, which company is doing that, and whether or not they have a product, and whether or not it's open source.
Yes.
And the first, the traditional secret sharing thing, what do you call it? Is it Shamid method?
If it's just like the one you would use for backup is probably just Shamir secret sharing. Or actually, in this case, in this case, you mentioned where we expect all parties to take part. It's even simpler. It's just additive secret sharing. It's basically just the sum of values modulo some number.
No, we actually need threshold because we cannot guarantee the availability of parties. So so although the users are no longer a party, that means we should not need threshold. But we are sharing the key between a few organizations, and one of them will bankrupt. That's a different scenario because in the blockchain world, every company bankrupts once in a while. So it's a different world. So actually, 2 out of 3 is still needed because of that.
I see. Yeah. Then it's Shamir secret sharing.
Okay. I'll write a title Shamir secret sharing. Then we discuss the parameters. We discuss what's good, what's bad about it, and then we will close this conversation. Okay.
Yeah. Great.
I started 3 email threads. Thank you. That's all I need. And 45 minutes exactly.
All right. Great.
Okay. Yeah. Okay. Talk to you
later.
Care. And take care of your health. Yeah. Okay.
Yes, you too. Are you well after the surgery, by the way?
Oh yeah, I'm good. I think I don't know if my sleep has improved because I still sleep 9 hours, but I don't know if it's habitually or if the operation actually didn't work. So I bought a watch which is called sleep monitoring watch. and we will know the result soon, because then every night when I sleep, I forgot to put it down. So
okay.
So I will find out if my sleep has improved in a few weeks, in a few days. Yeah.
All right.
Okay. Thank you very much. Yeah. Talk later.
You're welcome. Take care. Bye.
Bye. OK，快休息。 你这样不用平板，我就把它们微信通上了，要是你微信通上。 我要灰的，更高级。为什么那个你的这个照片没有自动上传到 Google Photo 里去？你不是 Google 手机吗？ 让我看看你的选项是不是我设置了一个什么东西。不是的，设置的问题。我给你上一个视频，就是以后你要是看什么东西，比如说你看到一个商品，你想把它拍下来，连着你忘掉它的型号，那么你就要用 Day One 拍，不要用 Google Photo 拍。我不要用 Day One。Day One 拍起来，有的时候想要拍的挺想尽快的好。如果你是想拍的产品的话，你就不是最快的，最快的一般都是普通人的时候。对，有的手机你不想要那个，记它的名字啥的。因为那个照片，你的 Google Photo 里面太多东西都不相关了。你做照片 Photo 的时候，你一半的东西都是那个跟我们家人和我们的生活有关系的东西。但是 Day One 只能一次拍一张。是吗？如果反复拍多张，它就会记录多个不同的事儿，是吧？对。我们也是在想，你看，每次跟他讲长达他的口水。 你在问宝宝什么时候睡觉吗？ 宝呀，你这个像狗一样到上面跑3年，怎么管理你？我想我厉害。OK，现在我得离开这儿了，不然的话这个地方没法收拾。我们去那边吧，就是去电视机那边吧，这样的话它可以玩的东西比较不精细一点，这地方都是太 dedicated 了，随便他玩什么东西也不行。嗯， 你觉得他会睡着吗？ Hello, Lucas. Hi, Lucas. So it's sorry for interrupting you. Can I speak? Yeah. So it's my habit that if I see text communication is on the edge of miscommunication, I will reverse to call. So yeah, just, this is just how I do things. Okay. So his concern is that somebody else will start a recovery process and type his email address, and he will be bothered with confirmation message. Yeah, yeah. But if it's not, if he doesn't get it in the beginning, he probably won't get it. Most users will look at it and decide how it works. That's the problem. Yeah. Hmm. Well, if he likes Google Connect, then we can pursue that route. Uh-huh. Yeah. So if they think multi-step is not for their benefit, then it's really at different times people say different things. Previously, we got a message saying that our process was too simple, so the user think that we didn't secure stuff. So actually, sometimes it's a boo, but sometimes it's a bonus. But I would not give any opinion here. It's just, I'm not on that front. I'm just want to let you know that if the user likes the idea of having uh, which is something Victor talked about before, having Google Connect and like plus Facebook Connect. This is still considered secure because normally you have what you know and what you have, and in both cases is what you have. But Facebook and Google independently did a lot of work to secure their account as much as they could. So they are already considered higher security than just username password. So if a user decide to share his Facebook ID and Google ID to parties equally, like every party have this knowledge, and then he start recovery process, then it's still considered acceptable as long as it makes sense to the users. I'm bringing it up not because I'm recommending it, but because just examining the security aspect of it. Mm, mm. Yeah, it's pretty challenging to think about it. Even if I see this screen, I wouldn't understand what's happening behind it. Yeah. Yeah. I guess yeah. Yeah, okay. Sorry. I guess the way we work is that you bounce these things, different designs or different process with the users, and then bounce back to me. And I will simply be examining whether or not it's still technically possible without too much overhead development. and securely not worse than for example, storage-based solution. It has to be higher than that. But then as long as but this works, yeah, just use your creativity or whatever. Apple ID is acceptable. Facebook is acceptable. Google is acceptable. Yeah, yeah. And mm, mm, mm. Yeah, 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 yeah. Okay, yeah. Yeah, okay, thank you very much. Please go on with this, and thank you for identifying the bad energy from that. Yeah, just bounce it back to me anytime you have some improvement ideas, okay? Yeah, okay, thank you very much. Yeah.